Hi everybody, here's Friday's maths lesson. I hope that you're all okay and looking forward to the weekend. Well done for all of your hard work so far this week. Here's today's starter, so I'm going to start by reading it out and then you can pause the video and have a think. So, Nathaniel bought 9 apples and 6 oranges, which altogether cost £63. On another occasion, he bought 8 apples and 6 oranges, which cost £60. The fruit was very expensive. How much does 1 apple cost? How much does 1 orange cost? And the hint at the bottom, the answers are whole numbers. Okay, so the most expensive fruit that I've ever seen. Definitely will be buying from this shop. Pause the video, have a think, and in a moment I'm going to reveal a few clues. Hopefully you'll be able to do it. Okay, I'm now going to start talking through a clue. So if you are still working, pause the video. So I think most of you may have been able to work this out by just using your logic and actually looking at the problem. But if not, you could express it algebraically. So I wrote down 9a add 6o equals £63. So that means 9 apples add 6 oranges cost £63. And I wrote the other one underneath it. Pause the video if you've not finished and just look at the equations and just see, does that help you to work out? It should help you to work out the cost of one of the items of fruit. So have a go. Okay, I'm now going to explain a little bit more. Don't worry if you've not got it. We'll do some more of these types of questions next week. We didn't do too much of algebra when we were in school, but we'll definitely do some more in the future. So I took them away. I found the difference. So I thought, right, I'm going to work the difference out. So I did £63, take away £60, which is £3. The oranges cancelled out because there was the same amount of oranges purchased each time. And that meant that I was left with 1 apple. So I now believe that 1 apple costs £3. Right, so then I moved on. If you haven't got the oranges yourself, you may be able to work out how much an orange costs now using that fact. So you might want to pause the video. Otherwise, let's keep going. So then, this looks really complicated, but it's not. So then I put the knowledge that £3 is an apple back into the equation. So I took the highlighted equation. So I did 9 multiplied by 3 is 27. So I know that in that bill, the apples cost £27. So £27 add 6 oranges equals £63. Okay, so now I'm able to work out what the total cost of 6 oranges is. So I did 63, take away 27, and I got 36. Then I shared 36 by 6 because there are 6 oranges and I got 6. So now I'm pretty confident that the oranges cost £6. Now just to double check, I'm going to put my information back into the other equation to make sure that it works. So I believe that apples cost £3 and oranges cost £6. So 8 times 3 is 24, 6 times 6 is 36, and 24 of 36 equals 60. So now I'm certain that I've got it right. Now, a little warm up again. So I've put a quiz on the screen. I'd like you to test your knowledge. So I'd like you to pair up the fractions with the correct decimal equivalents. So to make it easier for yourself, you might want to use the numbers and letters. So you might say, this is not the answer, but you might write down that 3 equals C. Okay, if you think those are a match, write that down on your piece of paper because that will help you to mark it. But equally, it might be worth actually writing down, this is not correct, but it might be worth writing down 9/10 equals 0.125 because then it might stick in your mind a bit more, and also if you've got them right, it'll be a good resource to keep to revise. Okay, so pause the video, think really carefully. If you've completed the previous lessons this week, hopefully you should do quite well. Have a go. Okay, I'm now going to reveal the answers on the screen, so if you've not finished, then you need to press pause. Now, it's a bit overwhelming when you look at this screen. So much colour. But I have paired them up using colour. So 1/100th equals 0.01. 1/5 equals 0.2. Okay, I'm not going to read them all out, but you get the idea. At the side here, I've also labelled some equivalent fractions, which also, so for example, 0.25 is 1/4. That's the simplified fraction. But you could also express 0.25 as 25/100ths. Okay, so these might be worth looking at, might be interesting to see. And I've also written down what 1/3 really looks like. So you put a little dot above the 3 to show that the 3 is recurring. But that's something that you'll do more of in secondary school, really. So let me know how you got on afterwards on Teams. The work that I've seen this week has been really good, so I'm really pleased with you, so well done. Now, a little recap from yesterday. So yesterday we started to look at number lines, and we went through a few steps, and then you had to work out what the arrow was pointing to. So on screen now, I have obviously put a number line, 8, 9 here, an arrow there. I would like you to pause the video and just see if you can write down for me the mixed number, which this arrow is pointing to, and also the decimal. Then after this, I'm going to explain it step by step, and you can see if you got it right, or if you're confused by this, it might make more sense for you today. Okay, so pause the video, have a think. Can you do this? Right, I'm now going to start to explain the process and how you get to the answer. So what I think is really important, when you get a number line, where you've got like a little bit at the end, and a little bit at the beginning, and a little bit at the end, these can often catch people out. So what I always do is I look for a section where I've got a hole. So I've highlighted the 8 up until the 9 because that's the hole. So initially I'm not looking at the other parts because they're not really helpful to me at all. So I'm focusing on this yellow section. So that's step 1 for me. Step 2 is to visualise this section of the number line as a bar model. Okay, because then that makes me see quite clearly how many parts are in this hole. Okay, so I've drawn over the little lines, okay, and I've made it look like a chocolate bar, which is making me hungry now. So I can see that I've got 1, 2, 3, 4, 5 equal parts in the whole. Right, so now I know I'm talking about fifths. That's my next step. Okay, moving on. So then I label the fraction points. So 8's here, so that's like 8 wholes. So the little lines, so I go 1/5, 2/5, 3/5, 4/5, and 5/5 means a whole. So I don't really need to put that there, but I just put it to show you that means the whole. We've reached the next whole. Okay. So now I can put my decimal equivalents because I know that 1/5 is 0.2. So I've got 8.2, 8.4, 8.6, 8.8, 9. So that's really helped me now. Okay, so now I'm kind of ready now to look at the arrow. So I know that this arrow is pointing to before 8. So it's got to be 7 point something. Now I could just count back fifths, so I could just go, right, that'd be 5/5 because that's a whole. So 4/5, 3/5. Okay, that's what I would do. So I would write down 7 and 3/5. So that's the right answer here. I wonder if you got it right. If you still felt really confused, then you could compare this number line to the point over here. So I went, right, okay, well there's the whole. I've gone back 2 spaces. So I looked over here, so there's the 9, back 2 spaces. So I used this 8.6 to check that I was correct, and that made me really certain. There's a few strategies that might help you understand this a little bit better, okay? It's just really important that you work out how many parts are in the whole, otherwise you're going to go wrong. Okay, we're going to move on and look at a few sort of word problems now. So we're still using our decimal and fraction equivalence knowledge. Year 6 set off on a 2 3/4 kilometre woodland walk. By lunch, they had walked 1.5 kilometres. How much further do they need to walk? Okay, I would like you to pause the video and see if you can do this. Okay, you can express your answer as a mixed number or a decimal, or even better, both. Okay, think about what you've got to do. It's similar to what we were doing yesterday, because we did try a word problem, and in a moment I'm going to explain how to do it. Have a try first. Okay, so step 1. I labelled that 2 3/4 of a kilometre is the same as 2.75 kilometres, because I know that 3/4 means that 0.75. So if you didn't have a go and now you think, oh, I can do it now, you can pause the video and work it out. If not, let's just carry on. You might have already done it. Now, if the total walk is going to be 2.75 and they want to know how much further they've got to go, then it's kind of like find the difference. So all I did then was I did 2.75, take away 1.5, and I got 1.25 kilometres. So that is the correct answer. You could also express that as 1 and, hope you've said it, 1 1/4 kilometres, because 0.25 is the equivalent for a quarter. Let me know if you got that right, or even if you got halfway, that's still good. Next problem. I need 5.5 litres of cola for a science experiment. One bottle contains 1.5 litres of cola. How many bottles do I need? Right, okay, so this is a slightly different type of question to the one we've had previously. Okay, I would like you to pause the video and have a go yourself first, following the steps that we did before. So maybe you might want to turn this 5.5 into a decimal, or maybe you might want to turn this into a fraction or into a mixed number. Pause the video, see if you can do it. Okay, I'm now going to explain my thinking. So I made 5.5, I put it as 5.5, because that's what it means. Then I thought, right, okay, so I know that 1.5 add 1.5 is 3. 3 add 1.5 is 4.5, so that's not enough Coke still. So then I had to get another bottle. So actually I'm going to buy 6 litres of cola. I can't go into the shop and say, oh, sorry, can I just pour out a litre out of this bottle? Because you don't do that, do you? They think that you were going crazy. So I had to buy a little bit extra. So I've actually got half a litre spare, so I can have a nice glass after my experiment. So the answer is 4 bottles. Okay, did you get that right? Okay, here's another one for us to look at. So here are 2 parcels. What is the total combined weight of the parcels? Now you can see the scales. So I've actually drawn, so you would do this if you had it in front of you. Sometimes it's nice to actually draw on the scale to make it look like a bar model. Okay, I've done the same over here, and I've put little dots because now I can count 1, 2, 3, 4. So there's 4 parts in this hole, and there's 1, 2, 3, 4, 5 parts in that hole. So that really helps me when I see a scale, because I like to visualise the bar models. So hopefully now you're able to work out the fractions which are linked to this question. Okay, so have a go. You need to work out what the combined weight of the parcels is. So that's A add B. See if you can do it. And remember, the units that we're looking at is kilograms. Right, so this one, because it's pointing to the first quarter, so this is actually 1 1/4 kilograms. So I know that's the same as 1.25 kilograms. Probably in a test, I'd get a point for doing that. This would probably be a 2 or 3 mark question. B, well, it's pointing to 4/5. So this is 1 4/5 of a kilogram. This is heavier. So the decimal for that is 1.8 kilograms. So I may have got 2 points. It depends on how many marks it was worth. If you haven't finished working out the weight, maybe you are able to now pause the video and add these 2 totals up to see if you get the right answer. Okay, I'm going to reveal. So I then put them in column method, lined up my columns properly, put my decimal points in the right place. I could do this mentally in my head, but if I felt unsure, it's always safe to do this if you've got time. So the answer is down here on screen, so 3.05 kilograms. As a challenge, if you haven't already, can you express that decimal as a mixed number for me? 3 wholes. What fraction is 0.05? Okay, so you might have put 3 5/100ths of a kilogram, or we haven't talked about this much at all, so I'd be impressed if you got this, but the simplified version would be to say 3 1/20th of a kilogram. Okay, the best way to express the answer to this, though, would be to put the decimal. So we've done a bit of this before, earlier in the week, so sometimes you're asked to compare mixed numbers with decimals. Okay, so here are 3 strategies on screen, so you can pause the video and just have a little look at this and think about which method would work best for you. So they all work, you just need to think about, which one do you prefer, or maybe you'd prefer a certain method for a certain type of question. Okay, so on screen, this is the last task for today. I want you to put the symbols in the correct places. Remember that the gap faces the larger amount. So don't get caught out when you've got the same decimal as the same fraction. You need to think carefully. What I always do is I always make them both decimals. I find that easier and quicker. Okay, so I would write down what 1 1/5 is as a decimal, and then I'll make my decision. You could equally go the other way, but remember you can't compare fractions unless they've got the same denominator. So you've got to be a bit more careful, so it can be a bit trickier. Pause the video, see if you can do it. Okay, I'm going to reveal the answer, so pause if you've not finished. Okay, so 1 1/5 is the same as 1.2, so 1.5 is greater. These are equal. Okay, hopefully you didn't get caught out. 1/4 is not the same as 0.4. Okay, 1/4 means 10.25, whereas this is 4/10, so that's like 40p versus 25p. So 10 1/4 is smaller. This one, you could have got caught out if you were rushing. I just looked at the holes, so this has got 6 holes, and that's got no holes, so straight away I know this is larger. This is like £6.50, and that's just like 62p, isn't it? Right, well done for all of your hard work this week. I've enjoyed seeing your work, so I'm hoping you're going to share with me again today, and hopefully you'll come back next week on Monday.